When it is not feasible or guaranteed to safely discharge or reuse effluent from the treatment plant, infiltration offers an alternative solution. Infiltration is the process of water, wastewater, or treated effluent penetrating from the ground surface into the soil. It involves the controlled and gradual percolation, both horizontally and vertically, into the subsurface soil. It allows a final treatment step for effluent following primary and secondary treatment. As treated effluent percolates through the soil, various physical, chemical, and biological processes can remove remaining contaminants and further improve effluent quality. Percolating through the soil, the treated effluent will eventually reach the groundwater reserves. It can recharge aquifers and maintain a sustainable supply of groundwater. In this context, infiltration may be a solution to the increasing demand for additional water sources. To consider infiltration as part of a treatment process and do not pose any risks to human health or the environment, a variety of conditions need to be fulfilled. Firstly, setback distances need to be respected. The location of infiltration systems must respect a minimum distance from other existing works infrastructures or natural elements to ensure a sufficient buffer to prevent any potential contamination or health risk. Local regulations might exist and specify the requirements. A general rule is, for example, that wells or springs used for water supply should be 30 to 35 meters away from the infiltration point. Lakes, streams, or other water bodies are recommended to be at least 15 meters away from the infiltration point. Secondly, soil suitability is crucial. The soil where infiltration is planned should have suitable properties for effective filtration and percolation. Properties such as soil texture, structure, permeability, and depth to the water table need to be considered. Soil testing and analysis, such as a percolation test, are commonly conducted to assess soil suitability. Experiences show that the soil texture should be sandy or clay-loamy, while very fine sands and heavy and expandable clays are not favorable. Soil structure should be granular and blocky instead of platy, prismatic, or massive, as it would hinder percolation. Thirdly, the proper pretreatment, including primary and secondary treatment, of effluent before infiltration is critical. The adequate pretreatment will remove solids and contaminants that could harm the infiltration system or the receiving soil. The effluent should be tested to guarantee that it is suitable for discharge into an infiltration system. The recommended BOD and TSS levels for effluent to be infiltrated into the soil depend on soil texture and hydraulic loading. Fourthly, the management, scheduling, and loading are important for a sustainable infiltration system. The rate at which effluent or wastewater is introduced into the infiltration system needs to be carefully controlled to avoid overloading and potential harm to the environment. The system should include a dosing system that applies proper scheduling to ensure adequate loads and time between loads. Also, ensuring that an even distribution of effluent across the infiltration system is realized is essential. In the following chapters of this training, we will learn more about these requirements.